Okay, here's another question. The period of a simple pendulum X is 5 seconds. What is the period of a simple pendulum Y, which makes 50 vibrations? In the same time, it takes X to make 20 vibrations. I'm going to be solving this question in this video. How do we solve it? Okay, let's use this equation. The period is given by the time taken to complete a number of oscillation n, where n must be an integer. This is what we're going to use. So we form this equation. Maybe we can follow this approach, or we can even, since you are given a period of pendulum x, I can call that tx 5 seconds. And we are given a number of oscillations completed by pendulum x. Let's call that nx. And that is what? In the same time, it takes x to make 20, so 20 vibrations. So that for me, I can find the time taken for pendulum x to make this number of vibrations, that is 20. So my time t here is n multiplied by t if I cross multiply. So that gives me 20 times 5. 20 times 5 gives me 100 seconds. So it takes 100 seconds for the pendulum x to make 20 oscillations when it is vibrating at a period of 5 seconds. But we are not to stop there. We are to find the period of a simple pendulum y. So what will be its own period? Now for this one, let's call that t subscript y. It's also giving us time t over number of oscillations completed by pendulum y. Let's call that ny. Now we have to find ty, that's unknown. And then the time t is what? Now since we are told that the two pendulums completed their respective number of vibrations in the same time, what is the period of pendulum y, which makes 50 vibrations in the same time? So which means this 100 seconds, which is the time taken for pendulum x to complete 20, in the same time is going to take pendulum y to complete 50 vibrations. So we're going to use that 100 there. So that ty equals 100 divided by 50, which is the number of oscillations for pendulum y completed by pendulum y. So that will give me 2 seconds. All right, so that is the solution to this question. Okay, let's take one more before we wrap up this section of solving questions that borders on a simple pendulum. Look at this. A pendulum of length L has a period of 1.5 seconds. Let's call that a t 1.5 seconds. Now they say what will be its period when the length is doubled. Suppose the length is doubled, what will be the period of that is, let's be the initial length of the pendulum when the period is let it be the initial length when the period was 1.5 seconds. So that this equation that relates I can call, because they didn't say anything about g, so let's take constant k as 2 pi over square root of g, so that we have this one. I'm going to use this relation to solve that problem. So when this was 1.5 seconds, okay, sorry, this is L, don't mind me, this was k square root of L, okay. Now we need to find the period, I should call that t1, when the length is doubled. The second condition is that L becomes 2 times L, because when we manipulate the length, we don't expect the period to be the same. That's one thing about equations like this, when a relation between t and the length of the pendulum. So whatever happens to the length will also affect the period, because the period is dependent on the length. It's directly proportional to the square root of the length. So I don't expect the period to remain 1.5. Maybe I should call this equation 1 and then call this equation 2. I'm going to solve them again simultaneously. Okay, so I'm going to apply the rule of third here. Let's say this is 1.5 from equation 1 over t1 is equal to, that's dividing both sides. I'm dividing now, dividing the two equations, or 1 by equation 2 by 1. This cancels this. So I'm going to have L over 2L. This is outline the rule of third. The square root of this over the square root of this, and give a common square root into this over this, so that L cancels L. What is left is 1 over 2 square root. Okay, so that is what we have there. Now we need to quickly make the T1 the subject of the equation. If I reciprocate this, I have T1 over 1.5, or invert this one will give me 2 square root of 2 over 1, which is same thing as the square root of So if I cross multiply, what's my T1? T1 is 1.5 times the square root of 2. So I can quickly multiply this. I don't need to take square root again to make my work fast. So I can have square root of 2. Square root of 2 gives me this, then times 1.5. I'll confirm that. That gives me 2.12 seconds. 2.12 seconds. That gives me the period of this pendulum. Okay, the next video will be looking at deriving the period of a vibrating mass, that is mass spring system. Thank you.